Hello friends and my dear students, I welcome you all to my channel. I hope you are all well and your studies are also going on well. So this is part 4 video on the chapter of parallelograms where I will discuss about squares, its properties, necessary conditions of a square, and will solve few problems on the squares. If you have not watched the previous videos, that is part 1 to part 3 on parallelograms, then I strongly suggest that you please watch those videos as well to maintain the continuity of this chapter. This video is part of the playlist CBSE Maths for Class 8 following the textbook of author RS Aggarwal. If you are new to my channel or not yet subscribed, and if you are watching my videos regularly and my videos are beneficial to you, then I strongly suggest and request that you please support me by subscribing to my channel, and also do not forget to press the bell icon so that you will be notified by my future videos. So let's get started with the part 4 video on squares on the chapter of parallelograms. Okay, so I have prepared the rough notes that I will discuss about squares, and finally after discussing the concepts, the theory on squares is very less. There is not much to learn about squares, and finally I will solve two sample problems. Okay, so what is a square? A square, a parallelogram having all sides equal and each angle measures 90 degree. So a square is basically a parallelogram where all the sides are equal and each angle of the parallelogram is 90 degree. That is, you know that a parallelogram is a quadrilateral where both the pair of opposite sides are equal and parallel. So, so if a parallelogram have all the sides equal and each angle measures 90 degree, then it becomes a square. So as you can see in this figure, ABCD is a square. So we must have, as per the definition of a square, we must have all the sides equal. That is, AB should be equal to BC, should be equal to DC, should be equal to AD. So these are the four sides of the quadrilateral or the square, and they are all equal. Also, each angle of the square, since square is a quadrilateral has four angles. All the angles must be equal to 90 degree. So we must have angle A is equal to angle B is equal to angle C. Angle C is equal to angle D. They are all equal and they are equal to 90 degree or one right angle. Okay, now let's quickly see what are the properties of a square. If you know that a given quadrilateral is a square, then what all information you will know about that quadrilateral. So first is that all sides are equal. So if ABCD is a square, then we must have all sides are equal. That is, we must have AB is equal to BC is equal to DC is equal to AD. Second property is that all angles are equal to 90 degree. So these are the first two properties are basically part of the definition of a square. So all angles are equal to 90 degree. That is, angle A will be 90 degree, 90 degree. Angle B will be equal to 90 degree. Angle C will be equal to 90 degree. Angle D will be equal to 90 degree. So we must have all the angles will be 90 degree. And in the first property, it says that all sides are equal. So we must have all sides are equal. All sides are equal. Okay. The third property says diagonals are equal. Also, the diagonals are equal. So we have the diagonals AC and BD. So they must be equal. They must be equal. That is, AC is equal to BD. Remember that in a parallelogram, the diagonals need not be equal. So if it is a square, then a special property of square is that the diagonals will be equal. Okay. The fourth property says that diagonals bisect each other at diagonals bisect each other at right angles. This is super important. The diagonals bisect each other at right angles. Now, bisect each other means that diagonals bisect each other. This is the property of parallelogram. In a parallelogram, the two diagonals always bisect each other. That is, they intersect at a point which is the midpoint of both the diagonals. So, let's draw the diagonals AC and BD. Now, bisect each other at right angles means if the point of intersection of the diagonals AC and BD is O, let's say this is O, then this angle, they intersect at right angles. So, this angle will be right angle, and also this angle will be right angle. This means that the diagonals AC and BD are intersecting at right angles, and obviously, so we will have angle BOC is equal to 90 degree, and also we will have angle AOD is equal to 90 degree, and also by the property of a parallelogram they will bisect each other, which means that DO will be equal to BO and AO will be equal to CO. Okay. Property 5 is also very important, that diagonals bisect each angles of the square. So if you draw the diagonals, what does it mean? By the fact that diagonals bisect the angles of the square. The diagonal AC is bisecting the angles, is bisecting the angle A and C. This means that this angle will be equal to this angle, and also this angle will be equal to this angle. Similarly, we will have the diagonal BD will bisect the angle B and D. So we can say that AC bisects angle A and angle C. Similarly, BD will bisects the diagonal BD will bisects the angle B and angle D. So this implies the diagonal AC bisects angle A and C, implies that angle CAB will be equal to angle CAD, and they both will be equal to 45 degree. Since the angle A is 90 degree, we know that every angle of a square is 90 degree. So angle A, B, C, D all will be 90 degree, and if angle A is being bisected by the diagonal AC, then obviously angle CAB, so this will be 45 degree. So angle CAB will be equal to angle CAD. They will be all equal to, both will be equal to 45 degree. Similarly, we will have the diagonal AC is actually bisecting two angles, the angles A and C. One second, friend. Okay, so the diagonal AC is bisecting two angles, bisecting angle A and angle C. So when angle A is being bisected by the diagonal AC, we are having angle CAB is equal to angle CAD, and they are both equal to 45 degree. Similarly, since AC is also bisecting the angle C, we will have angle ACB is equal to angle ACD, and they both will be equal to 45 degree. Similarly, the diagonal BD is bisecting the angle B. So we must have angle DBC should be equal to angle DBA, and they both will be equal to 45 degree. And we will have, since BD is also bisecting the angle D, we will have angle ADB will be equal to angle BDC, and they both will be equal to 45 degree. This is also very important, that the diagonals bisect all the angles and each of the angles are 45 degree. Okay, so these are the major properties of a square. Now let's see what are the necessary conditions for a quadrilateral or a parallelogram to be a square. So for a quadrilateral to be a square, there are two necessary conditions. The first one is that the diagonals are equal. If in a quadrilateral the diagonals are equal and the diagonals bisect each other at right angles, then it will be a square. The diagonals are equal and the diagonals bisect each other at right angles. So definitely, if we consider, if you try to draw a quadrilateral where the diagonals are equal and diagonals bisect each other at right angles, you will have something like, let's draw the two diagonals so that they are equal and they bisect each other at right angles. So let's say this is one diagonal, and let's say approximately this will be the midpoint. Let's say another diagonal which will be, let's say this diagonal is, I'm just giving some random endpoints, and let's say another diagonal will bisect the diagonal AB at right angles. So let's say something like this, and let's say this is PQ. If these two are the diagonals of a quadrilateral, so definitely the quadrilateral will be AQBP. AQBP, and you will see that AQBP will be a square. No matter what you assume the length of the diagonals, it will always become a square. So for a quadrilateral, if in a quadrilateral, if you found that in a quadrilateral the diagonals are equal and the diagonals are bisecting each other at right angles, it will be a square. Also, in a parallelogram, what are the necessary conditions for a parallelogram to be a square? If in a parallelogram, any pair of adjacent angles are equal, so let's say I will draw a parallelogram. It will not look like a square. So this is, let's say this is a parallelogram, but eventually this will be a square. So it says that if in a parallelogram any pair of adjacent angles are equal, let's say these two angles are equal. Now we know that in a parallelogram the sum of any two adjacent angles, let's say the parallelogram is ABCD, the sum of any two adjacent angles in a parallelogram is always 180 degree. So A plus B, angle A plus angle B will be equal to 180 degree, and if it is the case that these two adjacent angles A and B are equal, we will get that angle A plus angle A is equal to 180 degree. This will imply angle A is equal to 90 degree. So if angle A is 90 degree, we will automatically have angle B is equal to 90 degree. We will then automatically have the opposite angle to B. We know in a parallelogram the opposite angles are equal, so angle D will be equal to 90 degree. Similarly, angle C will be also 90 degree. So we can see that if any two adjacent angles in a parallelogram are equal, we are having that all the angles of the parallelogram are 90 degree. So in a parallelogram, if all the angles are 90 degree, it becomes a rectangle. It does not become a square yet. It becomes a rectangle. Now, if the condition B is satisfied, that is diagonals intersect at right angles, then it will become a square. That is, if in a rectangle, if you consider a rectangle, if the diagonals are intersecting at right angles, it will be a square. So in a parallelogram, if any pair of adjacent angles are equal, or you can say that any angle is 90 degree. If in a parallelogram any one angle is 90 degree, means all the other angles are also 90 degree. The condition A the condition A can be any pair of adjacent angles are equal, or any one angle is 90 degree, and condition B is diagonals intersect at right angles. If these two conditions are satisfied in a parallelogram, it will be a square. Also notice that even though I have not discussed about rectangle and rhombus, please note that a square is a parallelogram, it is also a rectangle, and it is also a rhombus. Okay, so this was all about the geometrical concept of a square and its properties. Now let's solve. I have only two problems. I will solve two problems. These are good problems. Try to solve these problems on your own. So pause the video and try to solve the problems on your own. If you are stuck, then only you see the solution. The first problem says that in this figure, ABCD is a square. Okay, ABCD is a square. Triangle BEF and triangle FDE are two isosceles triangle. Okay, triangle BEF, triangle BEF, meaning this triangle this triangle is FDE. Sorry, this triangle is isosceles triangle. It is visually marked by the double stroke, and it is saying the triangle BEF, that is this triangle is also or isosceles triangle. So what is given? So we have in triangle FDE, we have FD is equal to DE. So this will imply that the opposite angles will also be equal. This will say that angle, we can say FDB should be equal to angle EDB, should be equal to no, sorry, I'm sorry, this is wrong. So we have FD is equal to DE. This means this will imply that angle DFE will be equal to angle FED. That is, this angle should be equal to this angle. Okay. Now also we know, also in triangle FDE we know that the angle D, the angle FDE, which is in triangle FDE, we have angle, the sum of the angles of a triangle is equal to 180 degree. So if we apply that concept, we have angle FDE plus angle DFE plus angle FED is equal to 180 degree. Now angle FDE is nothing but angle D of the square, plus we can say that since angle DFE and angle FED are both equal, we can say angle DFE plus angle DFE is equal to 180 degree. So this implies angle D, we know in a square all the angles are 90 degree. So we have D is equal to 90 degree. So we have angle D plus twice of angle DFE is equal to 180 degree. So this implies twice of angle DFE is equal to 180 degree minus 90 degree. This is equal to 90 degree. So this implies angle DFE is equal to 90 degree by 2, which is 45 degree. So angle DFE is equal to 45 degree. So we can say this angle is 45 degree. Okay. This angle is given to be 70. We are asked to find then what is the value of x. This angle, we have to find the value of x, Angle DBE is given to be x degree and angle AFB is given to be 70 degree. Then what is x? What is the value of x? That is, we have to find the angle x. Okay. So this okay. So this will also be 45 degree. This is 45 degree. Now we have we must have let's say so let's say if this is y degree, if this is y degree, let's say if this is y degree, since angle and also in triangle, the in other triangle, that is BFE, BEF, it is given that BF is equal to BE. This will imply that angle BFE is equal to angle BEF equal to angle y degree. Let we are assuming that let these two angles be y degree. This is also y degree. Okay. Now we must have we know that sum of all the angles on the same side of a straight line is equal to 180 degree. So we must have 70 degree plus y degree plus 45 degree must be equal to 180 degree. As 45, the 70 degree and y degree and the 45 degree, they are all angles on the same side of the straight line AD at the same point F. So their sum should be equal to 180 degree. Okay. From here we easily get the value of y. So y degree is equal to 180 degree minus 45 degree minus 70 degree. This is equal to 180 degree minus 115 degree. This is equal to 65 degree. So y degree is equal to 65 degree. We have to find x. We have to find x. Okay. We have to find x. Okay. Now in triangle BDE, because this is the triangle where we have the angle x. In triangle BDE, using the angle sum property, we must have angle BDE plus angle BED plus angle EBD should be equal to 180 degree. Okay. This implies what is angle BDE? BDE, this angle is 45 degree because BD is the diagonal of the square, and we know that the two diagonals bisects the angles of the square. So since angle D is 90 degree, so definitely angle BDC will be 45 degree, or angle BDE is 45 degree. So this will be 45 degree plus what is angle BED? Angle BED is nothing but y degree plus 45 degree. And what is angle EBD? Angle EBD is nothing but x degree. This is equal to 180 degree. This implies now y degree is, so this implies 45 degree plus what is y degree? Y we have already found to be 65 degree. So 65 degree plus 45 degree plus x degree is equal to 180 degree. So clearly now we can find x degree is equal to 180 degree minus, on the left hand side, if we simplify all the constant angles, we have 45 degree plus 45 degree, that is 90 degree, and 90 degree plus 65 degree is 155 degree. So we have 180 degree minus 155 degree. This is equal to mm, 25 degree. 25 degree. So the value of the measure of the angle x is 25 degree. So the answer is choice D. Okay. Let's see the next problem. Uh, in this figure, ABCD is a square. ABCD is a square. Okay. And angle DCE is an equilateral triangle. Angle DCE. So this triangle is an equilateral triangle, and obviously this is the square. Okay. Uh, D and E, D and E are joints. D and E are joints such that angle DEB. Oh, it will be not D, but it will be B. B B and E are joined such that angle DEB is Q degree and angle EBC is P degree. Then values of P and Q respectively are. Okay, so we have to find the measure of the angles P and Q. DEC is equilateral triangle. DEC is equilateral triangle means all these sides will be equal, and obviously since ABCD is a square, we will have all its sides equal. Okay. What do we? Okay. P. P. Okay. So since triangle DEC is equilateral, this implies that angle ECD is equal to 60 degree. ECD is equal to 60 degree. This angle has to be 60 degree since the triangle DCE is an equilateral triangle. Okay. And we must also have DC equal to EC. DC will be equal to EC as in an equilateral triangle all the sides are equal. Okay. Now in square ABCD, since all the sides are equal, we must have DC is equal to BC. DC is equal to BC. So using these two facts, that DC DC is equal to EC and DC is equal to BC, we must have EC is equal to BC. EC is equal to BC. So this will imply in triangle ECB we are having EC is equal to BC. So in triangle ECB we must have angle ECB we must have angle CEB should be equal to angle EBC. Now angle EBC is given to be P degree. Okay, so we must have this angle CEB is equal to angle EBC is equal to P degree. So this angle is also P degree. Okay, we need to find P. We need to find P. Okay, now we have found that ECB is equal to basically in triangle ECB is an isosceles triangle where EC is equal to BC. So we must have angle CEB is also equal to P degree. Okay, now angle sum property. Okay, also see that also in triangle ECB, the angle ECB is equal to the angle ECD plus angle DCB. So in triangle ECB, the angle ECB, we can say it is the sum of the angle ECD, and that is the 60 degree of the equilateral triangle, plus the angle DCB, which is basically, so angle ECD is 60 degree, as it is an angle of the equilateral triangle, and angle DCB is nothing but the angle C of the square, which is 90 degree. So this is equal to 150 degree. Angle ECB is 150 degree. Okay. Now, using the angle sum property, we can say we must have angle ECB, ECB plus angle CEB plus angle EBC must be equal to 180 degree. In triangle EBC or ECB, however you name it, the angle ECB plus the two other angles, the two equal angles, which is P degree, their sum will be equal to 180 degree. So angle ECB we have found to be 150 degree, and angle CEB and EBC, they are both equal to P degree. So we have this equation in P. So clearly we can solve for P. Simplifying further, we have twice of P degree is equal to 180 degree minus 150 degree, which is equal to 30 degree. So this implies P degree is equal to 30 degree by 2, which is equal to 15 degree. Okay, so P degree is 15 degree. Now how do we find Q degree? Okay. So, okay, now also see that angle DEC is an angle of the equilateral triangle, and this is equal to, angle DEC is equal to angle, we can see angle DEB plus angle BEC, which is equal to angle DEB is Q degree, and angle BEC is we have already found to be angle BEC. Angle BEC is P degree, which is 15 degree. Now, what is angle DEC? Angle DEC is nothing but one angle of the equilateral triangle, which is 60 degree. So we must have 60 degree is equal to Q degree plus 15 degree. This implies Q degree is equal to 16 degree minus 15 degree, which is 45 degree. So Q is 45 degree and P is 15 degree. So the values of P must be, value of P must be 15 and value of Q must be 45. So 15 and 45 should be the answer. So we have P is equal to 15 and Q is equal to 45. This is the result. So the correct choice will be A. A is the correct choice. Okay. So this brings to an end in the discussion of the squares with two sample problems. Similarly, I will discuss the other special figures like rhombus, trapezium, rectangle, isosceles trapezium, and kite. And then I will solve the two exercise problems from the textbook of author RS Aggarwal. If this video was beneficial, please like it, share it with your friends, and once again, please support me by subscribing to my channel, and also do not forget to press the bell icon so that you will be notified by my future videos. Once all the figures, the rest of the figures are complete and the two exercises are complete, I will start solving relatively harder problems in the other playlist, that is Maths 8 Hot, on this chapter of parallelogram. So please stay tuned and keep an eye also in the other playlist, that is Maths 8 Hot. I will end the video here. Thanks for watching, and until the next video, take care and bye.